Hi, I'm Tom Dean. I'm a field engineer here at Buoyant, and I'm here with Flynn, who is our tech evangelist.
Hey, how goes?
And today we are going to take a look at some of the new features in Linkerd 2.15, and Flynn's going to demonstrate those to us. Some things we're going to talk about are high availability zonal load balancing, or HAZL, which allows you to keep traffic in AZ when possible and saving you money over ingress and egress costs. We're going to talk about mesh expansion, which allows you to bring workloads on Linux outside of Kubernetes into your service mesh. And we're going to talk about the new support for native sidecars in Kubernetes. And I'm going to go ahead and hand that over to Flynn.
Excellent. So let me also begin by pointing out here that some of you will have seen some of my other demos here. And it's a little bit more possible that this one is going to break than some of the other ones. So everybody cross your fingers. Should be fine either way, right? So we are going to talk about HAZL and native sidecars and mesh expansion. I would love to point you all over to KubeCrash as we get started here. That is next week in just 6 days, where we're going to be talking about platform engineering using all sorts of awesome open source things. Should be a good time. And with that in mind, oh yeah, and the keynote of that is from Spotify, so that should be kind of fun too. So we also have the previous KubeCrash book on a zero trust reference architecture, which is also a great thing to go and take a look at. All right. With those words from our sponsor out of our way, the agenda for today, we're going to do a very quick discussion, kind of looking over what all these three features are, and then we're going to dive into a demo. If you want to follow along, there's the source. It's the 215 features directory in the Service Mesh Academy GitHub repo. Please note, brand new thing in Service Mesh Academy, this demo, we will be using Enterprise 2.15.2 rather than an Edge release because we're working with enterprise features like HAZL. That means you will need to follow along. You'll need a free Buoyant ID that you can get from enterprise.buoyant.io. I promise you, it really is free. We're not going to sell all of your email addresses and send you all spam and everything like that. It's really not that big a deal. You will also need Kubernetes 1.29, not 1.28, 1.29. The demo will walk through setting up a K3D cluster that does all of the things we need. So you'll get to see that. And you will need all the usual suspects on the command line. I'm not going to go over all of these, except to point out that if you are following along, there's a requirement script in the demo script that will check all these things. I also did not list a URL for Python, but yeah, you'll need Python to do a couple of things in here. All right. With that out of the way, let's dive into some of the features. We will start with HAZL, the High Availability Zonal Load Balancer. This is also a reasonable time to talk about the demo that I'm going to be showing off here, which is our ever popular Faces demo, where we have a GUI that goes through and talks through, in this case, emissary ingress to a face workload, which talks to the color and smiley workloads. Color is supposed to give you back a color. Smiley is supposed to give you back a grinning face. The face workload puts those together, and then that's how the GUI knows what it should show. But suppose that this is a multi-zone cluster. And further suppose that we have instances of our color workload in all of the zones. If we don't do anything special, then the face workload will end up spreading its traffic across all three zones because, hey, that's just the way Kubernetes wants to do things. Unfortunately for us in practice, it's usually more expensive to go and talk outside of our zone. So what HAZL does is it gives us this option where we can just keep, if the face workload is running in the east zone, it will always talk to the color workload in the east zone, unless something goes wrong. And the unless something goes wrong part there is the really important part of what HAZL is doing. In our demo today, I'll also point out that we will have color running in all three zones, and it will be doing a different color depending on which zone it's in, just to make it easier to see what's going on and to make it blatantly apparent when we have traffic that's crossing zones or not. All right. Mesh expansion. We've talked about mesh expansion before in a Service Mesh Academy. The big difference here is just that we're going to be showing it using Enterprise 2.15.2 rather than one of the edges. So I'm going to go through this one a little bit quickly. The idea behind mesh expansion here is that you get to bring the mesh out of your cluster and onto workloads that are running on just plain old Linux machines. This has some advantages in that it's a way that you can bridge access out to a legacy workload that you have not yet brought into the cluster, which can make it very easy. Can give you an easy path to migrate that workload into your cluster, or could be a way that you just keep using it if it's not something you want to bring into the cluster. It also gives you access to a lot of smaller devices. The Linkerd proxy is very lightweight. It will run quite happily on a Raspberry Pi. And so you have the option of doing a bunch of things with Internet of Things edge devices. All right, Tom, you're playing with the comments. What's going on?
Sorry, I was just trying to get my comments out for myself so I can keep an eye on them. Remember, if you need to comment on something or you have a question, we're going to take comments at the Linkerd Slack, and that's right up here. So I didn't mention that up front, but just wanted to make
and
sure.
I should have mentioned it up front.
Yeah. We missed it. We're so excited about these new features.
The Workshops channel is the best way to do this one. If you're watching it on a streaming platform, you may be able to post a comment there and we might see it, but the Workshops channel is 100% the best way to do it. Okay. Mesh expansion, in addition to having some kind of cool things with what you can do, given that the implementation is basically that we're still running the Linkerd proxy on the Linux system and still tweaking up IP tables, you get some interesting challenges, the biggest of which have to do with trust across this whole thing. There are some interesting things with the network and with DNS. And yeah, right now it currently assumes that you're running your workloads on Linux. So we will be showing that today. And the last major feature we wanted to look at here is native Sidecar support. This is a brand new thing in Kubernetes 1.29. It actually was an alpha feature in 1.28, but in 1.29, it's actually there for everybody to use. Basically, for example, if you ever tried to run a job with the Linkerd proxy injected in Kubernetes, you would see that it would never complete. And the reason for that is that your job's application container would run, everything would be happy, and then Kubernetes would be going, well, there's still this proxy container running, so this must not be done. But there was no effective way that you could shut down the sidecar reasonably. So KEP 753 finally fixed that and introduced a way that you could actually just tell Kubernetes, hey, this sidecar over here, don't worry about it. Let the job complete anyway. That, I think it's technically beta in 1.29, which is effectively available for everybody, and Linkerd supports it as of 2.15. So we're going to show that. All right. Now is a fine time for any quick questions before we actually start the demo. So if anybody has questions they want to bring up, toss them our way. Otherwise, we shall get started. And we shall also, oh, yeah. This is how you know we're doing it live, folks. You just got to see a quick jump ahead to some of the stuff in the demo because I broke a chunk of script. Very auspicious beginning, right? So the first thing we're going to do here is we're going to use K3D to start a cluster that is running nodes in multiple zones. This is a little bit more complex than the usual way that we set up K3D. So rather than going through and having a really, really long command line, we're actually going to do this with a YAML configuration file, which we shall take a look at right now. First off, we're going to have one server node. We're going to have one agent node. We're going to call the thing features because this is the features service mesh academy. We will attach it to a network called features as well. This will be important for mesh expansion later. We will tell it to go ahead and bridge ports 80 and 443 from the load balancer in the K3D cluster to my host network on my Macintosh. And the reason for this is it makes it dramatically easier for me to fire up web browsers and talk to the application in the cluster. We are going to explicitly ask for Kubernetes 1.29. I think that if we don't do this, we get 1.28, and that will not work. We are going to disable traffic. I don't actually remember why I had debugging turned on, but hey, look, we have debugging turned on. And then last but very much not least, we are going to say that agent 0 is in the central zone, agent 1 is in the west zone, and agent 2 is in the east zone. So basically, each of our agent nodes is assigned into a particular zone. This is the way that you set up Kubernetes clusters so that they span multiple zones in only one cluster. You can also, of course, do multi-cluster, where each of your clusters is in a different zone. We will not be talking about that today. If y'all would like to see that done, then that would be a fine thing to leave in the workshops channel so that we can get that set up for you. Okay, so let's go ahead and fire that up. While I'm doing that, I'm going to lift that up a little bit to make it easier to read when there's stuff on the Chiron there.
There's all kinds of good code if you want to go out and poke around the Service Mesh Academy repository. Feel free to clone it. It's all out there.
Yep. And when you do clone it and you find bugs, as you inevitably will, let us know, or
Please
submit pull requests or open issues.
Or more like really something gets deprecated, right?
Yeah, there are a couple of places in the Service Mesh Academy where I'm kind of concerned about deprecation, and we haven't really had bandwidth to go through again. So yeah, we can go through, we can run the cluster info there, and we can see that we have a running cluster, which is great. Next up. So this is the point in Service Mesh Academy where I usually say, oh, we're just going to use the Linkerd CLI to quickly install Linkerd, but we're not going to do that today. Today, since we're working with Enterprise 2.15, we shall also use the Buoyant operator for Linkerd, whose job is to let you declaratively specify which version of Linkerd you want to run, and then let the operator do all the heavy lifting of actually getting it running or upgrading or configuring or whatever. This is kind of cool. This is one of the bits that requires you to sign up for a free account with Buoyant. Again, you can go to enterprise.buoyant.io. I did it. It wasn't that painful. And when you do that, you will get 3 environment variables that you have to set. They are all set in my environment. If they are not set in your environment and you try to run this script that I'm doing right now, it will complain at the very beginning, and you can fix it. Once you have them, though, we can go through and we can install the Linkerd operator. We will use Helm for that. Our usual dance, add the repo, do an update, and then we're going to do a Helm install. As we do this, you'll notice a couple of things, but the biggest one there is well, the first one there that I cleverly forgot to mention is that you also have to set this cluster name variable. The cluster name is important because, as we will see with Buoyant Cloud briefly in this demo, when you go over to Buoyant Cloud, which is sort of the enterprise version of Linkerd Viz, sort of, then it will use that cluster name for you. And so that's very helpful. The other thing that you'll notice, though, is that you need to give it the API client ID and client secret when you do the Helm install, so that the agent that we're installing here knows how to talk to Buoyant Cloud. So let's go ahead and get that going.
You'll see that he's got debug set too. You don't have to put those in there, but we use them a lot when we do demos. So by default, we tend to just stick them in there. So
there are so many places where the debugging stuff is handy as we're working on these things. Tom is thankfully not throwing me under the bus by telling everybody how late I was up last night working on some of this stuff. So I appreciate that, Tom.
Yeah.
Oh,
it's It's one of those things we just don't turn off, right? Because then you become dependent on running it because we're not running production. But if you're running production, obviously you wouldn't be enabling those unless you really needed them.
Y'all might have noticed this flew past a little bit quickly, but there's a Linkerd buoyant command with the Linkerd enterprise CLI. And so we're running Linkerd buoyant check just to make sure that everything is going okay. And it is going okay, although it's complaining about how it couldn't find a proxy container, which is because we don't actually have Linkerd installed yet. So we can't actually have the buoyant cloud metrics stuff injected with the mesh. So this is okay for the moment. We'll fix that in just a second. All right. Next up, certificates. We all love certificates. Certificates are so much fun. So what we're going to do here is just make a directory, and then we are going to run a couple of step commands to create certificates. I am again kind of doing this step a little bit quickly because this has shown up in so very many service mesh academies. But really quickly, the step CLI is all about manipulating certificates. It's a great tool, especially compared to OpenSSL. Here we're going to create a certificate. We're going to give that certificate the name root.linkerd.cluster.local, which is what the trust anchor expects. The trust anchor is the root of trust for everything that Linkerd does with MTLS. We're going to write its public key into this file. We'll write its private key into this file. We're going to tell it to use steps root CA profile, which turns out to be what we want for a trust anchor. And we are going to tell it we do not want to put a password on this thing. And yes, we know that's insecure. Go ahead and do it anyway. One of the things that's really nice about living in the future is how quickly we can generate certs now. When I got started with some of this, that command would have taken a couple of minutes to run. This one is exactly the same thing, but we're going to call our certificate identity.linkerd.cluster.local. We're going to write it into a different set of files. We're going to use the intermediate CA profile, which is to say, this is not a self-signed cert. This is an identity issuer certificate that will be signed by our trust anchor. And we're also going to explicitly say that this one gets to live for a year. Now, there are two things we're about to do that are a little less user-friendly than I would really like them to be, by which I mean, when I went through and started to do them by hand, I found that I was copying and pasting the wrong things. So I ended up writing stupid Python scripts to do it for me. The stupid Python scripts are not exactly supported, but man, did they make my life easier. So I included them in here. This one, what we're going to do is we're going to make a secret called Linkerd Identity Issuer in the Linkerd namespace. Since it's a Kubernetes IO TLS secret, you would think that we could just go ahead and do this with Kubernetes secret or Kubernetes create secret, but we actually need all three of these keys in here, and the kubectl command line doesn't really, the kubectl CLI doesn't really like doing that. So what we're doing here is we're creating a v1 secret named Linkerd Identity Issuer in the Linkerd namespace, and we're just explicitly filling in some keys with base64 files that we just created with step. That is all. There's no magic here. But the alternative is copying and pasting a lot of stuff. And like I said, I did not get that right. So we are going to run that and then apply it directly to the cluster so that we have a secret there. And off we go. Next up, we have to create a control plane CRD. And this is another one where I use a stupid Python script. This madness turns out to be how you get the Python YAML libraries to properly deal with multi-line string constants in YAML files. We're going to tell it which version we want to run. And then what we end up doing here is we have to put the version in the right place, actually in two separate places. We have to include the buoyant license that's in the environment. And we have to include the public half of the trust anchor to tell Linkerd, hey, these are the trust anchors that it's okay for you to see certificates signed by ultimately. So, oh yes, and we also have to tell it that it should expect to find a Kubernetes.io TLS secret for the identity issuer, which is the secret we just created. And that's that. So we're going to go ahead and run that. This one we'll actually take a look at instead of just applying it. And there you go. So we've got a bunch of stuff. There's the trust anchor. There's some stuff. Oh, crap. I guess I'm going to have to change my Buoyant license now. I'm sure Tom can help me with that. We'll go ahead and apply that. And at this point, the operator is running along, installing the Linkerd control plane for us. I can run Linkerd check, and we can wait for this to go, and everything will be happy. This is one of the fun things in demos. I don't know if this happens to you, Tom, but there are a bunch of times in demos where some of these operations take just long enough that I find myself going, oh crap, is it failing?
No, that's, the driving in the country situation where you wonder if you missed your road and you're just like, all right, just hang on. It's coming up.
It's coming up. It's
it's
going to be coming
road
up.
200 times, where I used to have a place at the lake and I drive the same thing. And at this one intersection, I always wondered if I'd missed it.
Yep.
I drive past.
That sounds so familiar. So after Linkerd check is done, you can see that our control plane is now marked up to date because, hey, the operator just went through and installed Linkerd for us, which is very cool. All right, we're going to finish this part of the setup by creating a data plane CRD. This will tell the operator, hey, I want you to get the Linkerd data plane running in that Linkerd Buoyant namespace. You remember when we did Linkerd Buoyant check earlier and it complained about not having a proxy? This will fix that. These are kind of cool. You're literally just give the thing a name and then tell it a namespace that it's in, and off you go. You can also tell it things like, if you want to, you can limit it to a certain set of workloads to mesh. In our case, we're just going to do all of them. So we'll do that one. The operator is going off and installing that. I am not going to sit there and watch it because of, on the one hand, because we don't need it. On the other hand, because there are a fair number of pods in there and I don't want to wait. So instead, let's get the app going. All right. The way I normally do faces, I use emissary as the ingress controller because it gets along nicely with Linkerd and because I'm biased. And then I have faces running, emissaries in the emissary namespace, faces running in the faces namespace. Everything is great. In this particular case, we need to do things a little bit differently because we're now running a multi-zone, multi-node cluster. So the first thing we're going to do is we're going to install 3 replicas of emissary, and we're going to use pod anti-affinity to make sure that we don't have 2 replicas running on the same node. This is actually the way you're supposed to run emissary, although it is not the way I've ever run it for an SMA demo ever before. Faces, similarly, we're going to have the face workload and the smiley workload and I think the face GUI workload, although I didn't mention it, in our east zone. And then we are going to install 3 different color deployments so that we can put 1 in each zone. But we're going to put all 3 of those behind the same service so that if you just reference color, then you'll get workloads that could be in any zone. The reason that we're using multiple deployments like this is, on the one hand, we get to independently scale them. But on the other hand, it's also the way we can have different colors in each zone. So we're kind of abusing the fact that service lets you select multiple deployments at a time, but only kind of, it's a supported thing. Also, if you just install faces in the normal way, every workload fails 20% of the time. We're going to turn that off because this is not a resilience demo. This is a HAZL demo. So emissary is fairly easy. We use the Helm chart, and then we use this custom values to set up pod anti-affinity. So we're going to go ahead and do that. Fire up a namespace, tell it that we want it to inject, and then off we go. This is another one where emissary takes about 30 seconds per replica. So we now have a minute and a half or so to kill while we do this.
So when we're talking about making data plane objects, right? The reason
Yep.
we do data plane objects, you don't need to. If you think of Linkerd and Boyne Enterprise Linkerd with the operator, there's two things you have. There's meshed workloads, which we do by annotating the workloads, right? So they'll be meshed, and managed workloads. Managed workloads means the operator's keeping an eye on them. If you update your control plane, you change your proxy versions, it's going to roll those out gracefully for you. It gives you some error checking in your configs, things like that. So you're putting those under management, right? You don't have to have a workload managed to mesh it, but I believe you would have to have one mesh to manage, or wouldn't make any sense, right?
You definitely have to have them meshed in order to manage them.
Yep.
Yeah.
So those are two different things to think about when you think about all these, kind of what we're doing here.
Yeah. And thank you for that, because that was a wonderful job of explaining stuff, while otherwise I would be sitting here going, oh my God, is my deployment working? So
I saw the opportunity.
Excellent. And as we run this -o wide thing, if you get the pods, does the nice thing of telling you which node it's running on. And you can see we have no two of these running on the same node. That's exactly what we wanted. So good to go. Next thing we're going to do is install Emissary's bootstrap configuration. I'm not actually going to talk through this on this one. This is the configuration that tells Emissary, go listen on ports 80 and 443, accept any host, and oh yeah, we'll throw a data plane in there as well. So now let's get faces going. Faces is a little weirder because we want to explicitly control the zones, and because the Helm chart is not really set up to do that right now. So I used Helm template to dump out all the YAML from the Helm chart and then edited the YAML by hand to get exactly what I wanted. So we're going to go take a look at that. Faces.yaml has things that aren't color in this example, basically. So we've got the face service, which connects up to the face workload. We've got the faces GUI service, which is connected up to the faces GUI workload, which is the thing that actually provides the YAML for the GUI, or sorry, the HTML for the GUI to load. Smiley service, all this is kind of normal stuff. Here's the big change. This is our face deployment, and we now have node affinity rules explicitly saying that this must be scheduled in our east zone. If we go scrolling through these, the error fraction is set to 0. That's the part that tells it, no, don't fail all the time, please. But if we go through all of these things, we will see the same affinity locking them all into the east zone. And that's really the change that I made here. Colors contains our color service. So explicitly, we are selecting things with a service of color. And then if we go through and we look at our 3 deployments, here's the color east deployment. This is the selector for the deployment selecting its pods. So it gets to use a different label, but we are going to label the pods also with service color so that our service can find them. The east deployment goes on to the east zone. If I come down here, the west deployment looks pretty much the same, except that it's on the west zone, in the west zone. It also has the green color. And the central central deployment is in our central zone, and it gets yellow. Finally, we have some bootstrap configuration, which again, we've got a data plane, we've got a mapping that tells Emissary what to do with the face path, and another one that tells it what to do with the faces path. So we're going to install all of that stuff. So now we've got the face workload, the smiley workload, and the GUI. Now we've got our 3 workloads for the colors. Now we should be able to talk to it through Emissary. Faces comes up nice and fast. It's kind of nice. And if we come take a look at this, then we can see that most things, smiley and face and faces and color east, are all running on agent 2. Central is running on agent 1, and west is running on, central is running on agent 0, and west is running on agent 1. So all of this appears to be working. And if we're really lucky, we can come over and see this in the browser. Yay! You'll notice that there are a lot of different colors going on in there. That is because we have not done anything to prevent that. So we're going to go and come back to that. But first, we're going to do a quick side quest about native sidecars. I have here a job that just uses the curl image to try to curl to the face workload. That's all it does. There's no magic here. So if I go through and I apply this job, then I can watch it run. We get initializing, and then we get running, and then we get not ready. This is not exactly ideal. If I quit this and I ask to look at the jobs, we will see that it has logged no completions, that it has not actually finished, but we can also see that it ran and it talked to the face workload and it got an answer. I realized that that answer might look a little strange, but that is in fact a fine answer to get from the face workload. So this is the problem with sidecars and jobs if you're not using native sidecars. The sidecar is still running, the job never finishes, nothing good is happening. So let's clean up that dead end job. To enable native sidecar support, we literally just set one thing in our control plane configuration. So we come down here. We have to find the proxy bit, proxy. Wow, I cannot type while people are watching. Save that, apply it. We will immediately see that the operator starts updating our control plane because we've just changed part of the definition of the control plane.
And the cool thing is you get validation. So if he would have typoed something, or say you were doing a version for an upgrade, and I've done this many times and put the wrong version in there because I was guessing, it won't do it. It'll just say no.
Yeah, I was. I actually was a little surprised that I didn't typo something there. You know, I typoed the capital I and then fixed it, and as I was writing it out, it's like, I wonder if I even got this right. You know. So there we go. Everything's going with that. If we now apply the job again, and then very quickly go and watch it, we see it init, we see the pod initializing, and now we see it's completed. Yay! And we can look at the output, and again, we got some good output. So this is kind of cool, actually. You'll notice I didn't change anything in the job definition. All I did was tell Linkerd, hey, use the native sidecar support, and it just worked, which is pretty awesome. This is, I mean, this is what we like to see with Linkerd, is things just work, but it's still always kind of fun. Okay, back to the main quest. Yeah, if we go back to the browser here, we see yellow, we see green, we only see a little bit of blue, despite the fact that blue is the one that's in the east zone and yellow and green are not. So that's a little odd. The reason for that is that even at this point, when we haven't explicitly done anything with HAZL, Linkerd already automatically pays attention to latency. And I have deliberately set this up so that color east has higher latency than color west or color central. It's kind of interesting to see that and to see how dramatic the effect is with that one. Although, I mean, admittedly, it's like double the latency for color east. So we can actually run, this is Linkerd diagnostics proxy metrics for things dealing with the face deployment in the faces namespace. And then I'm going to run this through a horrible Python script. Let's actually take a quick look at the horrible Python script. This is the kind of thing that we see coming back from proxy metrics. It's not terribly human consumable, although it is very informative. So what I'm basically doing in this is carving out the ones that I want and then doing a little bit of math for, you know, what exactly have they been doing. And that's in there in the repo, so you can take a look at it. But as we go through this, we can see that Smiley is getting all of the traffic from the face workload because there's only one Smiley. but between the other ones, it's mostly split between central and west, and east is taking a tiny fraction of the traffic because it's so much slower than the other ones. So this is a problem because Face is running in the east zone, and right now it's just spewing traffic all across the zones and probably costing us money, or, well, it would be costing us money if we were doing this in a cloud provider. So we will enable HAZL by the same trick that we just did, where we are going to go through and edit the control plane resource. The stanza we have to put in is a little messy, so I just copied and pasted it rather than trying to remember. And you'll note it says under linkerd.controlplaneconfig, so we can just stick it in up here and make sure that all the indentation is correct, because YAML is so much fun. Write that out. And now we get to watch it update again. This is the most times I've rolled the control plane ever in a Service Mesh Academy demo. Partly because it's so easy.
Yeah, it's nice to be able to see that. And now that you have those objects, control plane and data plane, you can check, the existence and the status of everything real quick too from the command line. You don't have to use GUIs, but that stuff is also available in Buoyant Cloud. You can look under Manage Linkerd and see the status of all that and see like the configuration, of your control plane. If you're like, oh, did I enable that one thing? There's a lot of things you can put in the custom resource definition to tune the control plane. We're working with a pretty base version here. So.
And in fact, that's a good segue to take a quick look at Buoyant Cloud, where we can see that we've got the control plane running. We can see that it is up to date.
Go under resources and then go to Manage Linkerd, and that'll get you your control plane and data plane information, which that's really, really nice to have if you just want to see how it's configured or you want to watch it during an upgrade.
Which is pretty awesome.
Yeah.
And thank you for that. I was just trying to remember where that was.
There you go.
And we get to go through and see all this stuff. It's really, cloud's kind of cool when you start looking at some of the managed stuff. Data planes, we get to see our namespaces. We get to see that they're up to date,
If you want to check your proxies on a managed data plane right here, this is a great way to do it. It'll show you which versions of proxies are out there. So if you think you got something stuck on an old version or whatever, it's real easy to kind of check it Proxy from here.
Version. Yeah. So there's a bunch of cool stuff you can do there. All right. So in the meantime, as we've gone through with this, we should see all blue at this point, but we don't. So at this point, we could go through and do a Socratic dialogue between myself and Tom, or we could go through and do all sorts of crazy things. I am actually going to cheat. Many of you may have noticed this already, but did anybody happen to notice this where, whoops, that's not what I want. If you come over and you look at this control plane, did anybody notice this version here? Originally, when I started this demo, I was talking about how we were going to do stuff with 2.15.2, but then I cleverly installed 2.15.1.
It happens.
That turns out to make a difference. Whoops. So let's do one more control plane roll, shall we? Let's just go ahead and upgrade this to 2.15.2. While we are waiting for this, so here we go. We get to watch the Linkerd pods rolling. We get to see that our control plane is updating. If I could find my mouse. This is kind of the usual that we've seen before. I'm also looking at the data planes because this is actually changing a version as opposed to just changing a configuration. And part of the point of all this operator stuff is to let it also manage more than just the data planes. And you can now, or the control planes, and now you can see, in fact, that they've all flipped over and say pending and updating, which is kind of cool. We can go through now and try to get a sense of what it's doing by looking at some other things. and we can see that it is actually doing a workload role for us in the emissary namespace right now. So the operator noticed that I changed the version of the control plane, and it is now going through and rolling all of my data planes for me so that I don't have to, which is a huge win.
Yeah, and then, again, like we said, there's a validator in there. So if he would have typoed the version or would have gotten optimistic and put like 2.15.4, it would come back and say, no, I can't do that. So it's protecting you.
And what we're going to do here is just sit here and watch for a little bit. Let's just repeat this, shall we? Wow, that's very convenient. The text just happened to wrap around the extra box. This is another one where it takes a little while for emissary because we've got all 3 replicas and they do them one at a time for reliability.
Yeah, the operator doesn't go out there and clobber your environment and take it offline.
Which is very, very polite of it. I mean, I confess I didn't worry much about whether it was going to do that the first time I tried this, but it did cross my mind.
Yep. Our customers do ask, and like, no, it's okay. And a lot of this stuff is configurable. I'm not going to say everything is down to the nth. And you also have to remember Kubernetes behaves in certain ways, because we get questions about why can't I do this? And it's like, because it's Kubernetes, because pods are, you can't change them after you and instantiate them, things like that. But we do follow Kubernetes patterns and, the way things happen. So if you know how it's supposed to work, we shouldn't be doing anything that's 180 degrees, from that.
Right. And I mean, let's face it, the rollout restart pattern is a reasonable pattern. So,
yep.
So now you'll notice that the face workload just rolled and now boom, everything is blue. How cool is that? What's going on here, and Tom can keep me honest, but my understanding of what's going on here is that in 2.15.1, HAZL was much more willing to cross zones than in 2.15.2. And the fact of the matter is, this is a fairly small amount of load. There's 16 cells. Every cell updates itself every 2 seconds. So this is 8 requests per second when all is working correctly. 8 RPS is not a really big deal. And you would expect that we would not see zones crossed with 8 requests per second and fairly low latencies. 2.15.1 was happy to do that. 2.15.2, you got to work at it to make it cross zones. So for example, suppose our color east deployment, which is the one that's giving us this nice blue color, suppose we just go ahead and kill that. And now immediately we've switched over and picked up another zone. This is particularly cool because if you have ever seen Kubernetes topology-aware routing, it can't do this. And this is a big win of HAZL. If we go ahead and bring this back, this will take slightly longer because it's got to go and bring it back in, but boom, we're back to all blue now as soon as the workload starts up again. Kind of nice. So that means that if you do take a hit on a zone, you get to take advantage of resources out of your zone as long as you need to. But when you don't need to anymore, it'll switch back and you'll now be staying in zone again. Another thing we can do is we can try to overwhelm color east and then see what happens. This is also a little slower, but what we're going to do here is just fire up a load generator. We're going to put this also in our east zone. So it will prefer hitting color east. And we are going to start this with 10 requests per second. You'll also notice that I'm actually pointing the load generator at the face workload and then letting face talk to color and smiley. And I will explain that when I get to the gotchas section at the end of this demo. So Tom, if I don't remember to do that, please call me on it.
Will do.
All right, so let's go ahead and do that. Not a lot should happen at 10 requests per second. Just the workload's fast enough, it really shouldn't matter. We can come over here to Buoyant Cloud and we can go to the topology display. The topo display is a little overwhelming sometimes. because of the amount of stuff that's actually going on in here. So what I'm going to do is click on this face zone and then tell it to zoom in there. And then I'm also going to click on the cloud metrics and tell it I don't want to see that one because that's not really doing me a lot of good. And if I refresh this, there we go. I can now see my load generator. And then I can come down here. I guess this window is a little bit tall to see that. Hang on a second. So I just changed the edge. Let me, in the graph sense, I changed the way the edges are labeled. So it's now showing me request rate. And as I go through and refresh this a little bit, okay, so now we've gotten up to about 10 requests per second here, and we can still see that everything is going to color east. And for those of you who are going, oh, wait, but if it's 8 from the browser and then 10 from load, we should be seeing 18 everywhere. Why are we only seeing 11 to Smiley? A lot of that is because of sampling intervals and things like that. So we don't have to worry about that too much. We're looking here at a sample section over the past minute, and it's good to bear that in mind. This is not an instantaneously updating thing. But again, if I flip back over here, we're still only talking to color east. If I look at the topology graph, it only says we're talking to color east. So let's just escalate things, shall we? We'll set that to 50 requests per second. Now, this will take, again, a little bit of time. But you can see that the numbers are changing. And it changed down. Great, thank you. That's because it had to roll the load deployment and pod. I should put in a feature request for auto updating this,
Yeah, Grafana has that. That's kind of nice.
There we go. All right. 31.7. Yeah. All right. That'll keep ramping up. Still looking good with just blue over here. But not anymore. Now we can see that Color Central has just come into the mix because we've gotten enough load. And if I come over here, hey, look, I'm getting a mix of blue and yellow. How cool is that? Unsurprisingly, if I then go through and, oh, whoops. You remember I changed the size of that window? Yeah. That actually switched all the way back to blue a little quicker than I was expecting it to. But looking at the Buoyant Cloud stuff, I believe that that's solely because we got lucky for a second. Now, though, now that I've dropped the load generator back down, aside from the odd purple frowning face, then yeah, we're back to all blue. So yeah, if we go through and we start hammering on the thing, then it will switch in and bring in resources outside of the zone as it needs to. If we lose our resources in a given zone, it will go outside the zone. But when those pressures drop away, we go back to staying within the same zone. It's really, the point is, again, both the high availability part and the zone aware part. If you are only going to do traffic within your zone, even if that isn't going to work, that doesn't really help you from the application point of view. You need both of those things, which is why HAZL is kind of a big deal. All right. Actually, before we get into mesh expansion, Tom, are you seeing any questions about any of this stuff so far?
Nothing right now. So again, if you have questions, feel free to join the Slack and use the workshops channel. And we've also got a Linkerd forum. We're not going to monitor that for this, but if you want to go up there, you can post questions, answers. That's another community we have around Linkerd. So another good thing to mention with HAZL is if you want to use it, it works with gateway free or flat networking, and you can do that across clusters. So if you're using a single network with 2 clusters and you use our multi-cluster extension, you can use HAZL within that, and it will load balance across zones, across clusters. So it's pretty cool stuff. I've actually got a demo I just put together for that. If you're using our gateway networking, you can't do HAZL across that. Obviously, everything goes to the gateway, and we don't have that. But with a flat network, you can build a data plane or a net mesh of pods across multiple clusters using a common network. So it's pretty cool technology, and it works. I've got a repo. We just had a brown bag session on HAZL. And if you want to play around with it, you can go out and go within the Service Mesh Academy. There's this eliminate cross-zone traffic with HAZL. If you want to take a look at how some of that stuff was done, how I did that, that's great stuff. And like I said, I'm working on getting a multi-cluster version of this kind of published so that we can share that with you if you want to try playing with that. But it's cool technology. It does work, and it can save a lot of money. You remember it works at layer 4. So if you've got something, we had a question from customer about, they had an application that everything was handled within the application right up at layer 7. We're not going to load balance at that level, right? We don't have visibility. We can't steer things, but you can get small advantages on something like that. If it's got some layer 4 traffic that can be optimized, you can get that out of it as well. So, but HAZL is one of those great new features in 2.15.2. And the other great one is mesh expansion, which, it has a lot of applications. Folks have workloads they don't want to migrate on Linux. They don't want to deal with. This allows you to kind of keep them in place and include them in your service mesh and, run them till retirement, right? So, and we got Flynn back. We'll give him a moment here to recover.
Everybody enjoyed listening to Tom cover for me while my machine lost its tiny little mind, I assume.
Oh, it happens.
It's always fascinating when that happens too, when you kind of look over and go, really? What? Why now? What are you just thinking there?
I have friends that go, oh, my phone is giving me problems. I'm like, well, when's the last time you restarted it? Oh, I don't know, a year ago. I'm like, remember, it's a computer, right? You had very good luck there.
Yeah. Let's find out, right? I think I restarted my computer only like a week ago. So, no, it just, my browser decided that, that the entirety of the audio path just dropped away, which was kind of fascinating. So, I guess I'm glad that happened at a nice breaking point in between the sections of the demo. That's great. I assume that if there are any questions that Tom has already answered them. All right, so let's go ahead and get back over onto mesh expansion. The first thing we're going to do for demoing mesh expansion here, actually, let me back up. So pretty recently, we did a Service Mesh Academy on mesh expansion where we went into a ton of the gory details. Given that we're already pretty much an hour into this Service Mesh Academy, I am not going to repeat all of the gory details. If you go to the Service Mesh Academy repo and then look in the 2.15 mesh expansion directory, you will find everything you ever wanted about how to do this stuff. In particular, a big part of the discussion about that in the earlier SMA was how do you actually build the workload that you're going to be running out on your Linux box? And I'm really not going to talk about that at all today. I'm just going to say, hey, we already have that Docker image built, and I'm going to use it from last time. So that by itself is an interesting and important point. Last time I was using one of the Edge releases of Linkerd. This time I'm using Buoyant Enterprise for Linkerd, and I'm using exactly the same image out on my external workload. So first things first, let's break everything by completely removing the smiley workload, which will make everything cursing faces. Now, we should fix that. And we will fix that by running the Smiley workload in a Docker container that is not part of the cluster, but is connected to the same Docker network, which is why I was saying it was important that we give that Docker network a name when we created the K3D cluster, so we could find it later, so we could connect it so that the Kubernetes cluster and the Docker container can both see the same thing. The other thing that I feel compelled to point out here is that if you saw the earlier Service Mesh Academy, we talked a bit about Spire. Spire is the basis for identity when you talk about mesh expansion. The way in which we are doing this is a horrible hack. We are running a Spire server and a Spire agent off in the external workload, and we're actually mounting the trust anchor's private key as a volume mount into that Docker container. This is not the way to do this in the real world. It's really not. And in an upcoming Service Mesh Academy, I am very much looking forward to doing this properly and showing y'all how to do it for real after we've now that we've established mesh expansion as a thing, we can get into how to do it in production.
Yeah, customers were very interested in getting this. So we had this proto release, right? Where it works, it's just not fully, it doesn't have all the nice pieces to get it in there on the full tool set, right? But that's coming shortly.
Yep.
So.
And the other, like I said before, the demo here is mesh expansion. We're not actually doing a Spire attestation demo. And so a big part of why we haven't tackled that so far is just kind of thinking through, how do we do that in a way that makes sense? What are some good practices that we can really point people to and show in a way that is reproducible and usable?
Yeah, like everything cloud native, you're always going to have these other pieces, and you have to figure out how, people are going to want to really use it and try and, follow what the right path is on that, right? And so that's part of what baking.
And unfortunately, when you talk about Spire attestation, a lot of that is not a technical decision. A lot of that is an organizational policy decision. And so you have to have, you have to talk about that. But in the meantime, what we're going to do here is we are going to talk about some of the nuts and bolts that we must have in place for this to work at all. One of which is IP routing. Our external workload has to be able to route into the cluster's CIDR range, the pod CIDR range specifically. We have 4 different nodes. We have a server and 3 agents. Any of them should, in the morally prescriptive sense, should be able to route. So we're going to use the server 0 node. Why not? And use that for routing. So that's at 172.26.0.3. We will also go and look up the pod CIDR. I probably don't need to look this up all the time because it doesn't change as I run K3D, but it might be different on your cluster. So we'll look it up every time. Kubernetes makes that easy. Next thing is DNS. It's always DNS. If the external workloads need to reference something by name, like face.face.service.cluster.local, that has to resolve. And this is a royal pain in the Docker world. What we're going to do is I'm going to cheat. I'm going to edit the kubedns service so that it exposes itself on a node port inside the cluster. And then I'm going to run a DNS mask container so that I can forward service.cluster.local using DNS mask through to the node port that I just opened up. The reason that you need DNS mask in here is that it is very, very difficult to get DNS clients to use non-standard ports. And there are really good reasons for this. But fortunately, DNS mask gives us an out here. We actually have a bunch of other options, right? We could have run a separate instance of core DNS. We could run something totally different. There's a lot of different ways, but this is a pretty simple way to do it. So I'm going to change this to node port, and I'm going to add node port 30,000 up here. I'm going to make sure that took. We can see that it did. Ports, right? That's now mapped. We see the port number. And I'm going to use this Dr. Sidechick DNS mask image. But I'm going to cheat and volume mount an entry point script for it so that my entry point can do the exact dumb thing that I want it to do. All it does is take service.cluster.local and forwards it to whatever we set DNS host to port 30,000. then it just sits there and sleeps forever because DNS mask is running in the background. So this is a kind of an ugly command, but it's not as bad as you might think. We want to run a Docker container. We're going to detach it. We're going to remove it once it's done. We give it netadmin so that it can bind on port 53. We attach it to the features network, which is the one that we put our Kubernetes cluster on. This is the volume mount for the startup script. We're going to have it run binsh as its entry point. We set an environment variable. We give it a name and tell it an image. And this bit is actually the argument to sh up here. sh-c user local bin dns forwarder.sh, just run my script. I'm doing it that way, explicitly running sh-c so that I don't have to think about whether permissions are crossing the volume mount correctly or anything like that. So there we go. And now we can get the IP address of the DNS mask container at 172.26.0.2 so that we can point that to so that we can point our external workload to that DNS server. All right. This is also a really, really ugly command. Here, we're adding the netadmin capability so that we can manipulate IP tables inside the image. I do not know why I said --net earlier, but spelled out --network here. They both do the same thing. We're going to explicitly point the container's DNS to our DNS mask instance. We are going to set its name. We are explicitly going to volume mount our certificates into OptSpire certs so that our Spire setup can find them. These things are all environment variables that the Linkerd proxy bootstrap setup expects to have. Specifically, those are telling it the workload when it runs the bootstrap script to tell Linkerd that this workload should be available as workload smiley in the faces namespace, and the node name is primarily a reporting thing. These last two environment variables are for the face workload itself to tell it to be a smiley workload and to set the latencies. And then finally, we have the image we're going to run, which I built last time. Once that is running, we are immediately going to exec into it and run an IP route so that it can talk to our cluster. So let's make sure that is running. DNS mask is running at the top. There we go. Here's our smiley container, DNS mask container, bunch of K3D containers. It's really nice having a machine that can run all this at once and not break a sweat. Now that we have our workload running, really quickly, we still don't have anything but cursing faces over here. And the reason is that we haven't told Linkerd how to talk to it. We haven't told Linkerd how to bring it into the mesh at all. So what we're going to do here is create an external workload resource, which is kind of analogous to a Kubernetes pod. It's a way of associating our name and IP address and all this other stuff, in this case, our MTLS identity, with the external workload. We need the IP address of our Docker container, and then we're going to use that to take this external workload template and turn it into an actual YAML file, which looks like this. This is an external workload. It has a name of Smiley. It lives in the faces namespace. These labels pretty much work the way that you would expect them to for services. And you'll see this. There is a service at the bottom of this file that we'll see in a moment. A lot of this is very much like some of the other things you see where you've got some ports. We tell it where the IP, we tell it where the workload is living. This is rather different. This is telling Linkerd, this is the identity that you should expect this workload to use when you try to contact it. And if this does not line up with the TLS identity that the workload is using, Linkerd will refuse to talk to it. Finally, another weird bit, Linkerd won't talk to an external workload until it has a status saying that it is ready. And normally, I shouldn't say normally, in the future, There will be some very cool stuff that actually keeps track of external workloads and marks them ready for you and does all these things. Right now, we just apply a status by hand so we can talk to it at all. And finally, we have our service. You'll notice it has a selector of workload name Smiley. And if we come up here, we have a label of workload name Smiley, even though this is an external workload. So let's go ahead and apply that. And at this point, we should be able to see some new stuff. We can see our Smiley service there. If I look for its endpoint slices, so this is the endpoint slice created by the Kubernetes endpoint controller, which only knows how to interact with services and therefore, only knows how to interact with pods and therefore doesn't see anything. This one was created by the shiny new Linkerd external workload endpoints controller. And so it knows how to look at external workload resources and fill in endpoints over here. One nice thing about doing it this way, though, is those are just ordinary Kubernetes endpoint slices. And so all of the things that you're used to looking at for Kubernetes work. And if we head back to the browser, we now have grinning faces again. Even though the colors are being supplied by a workload in our cluster and the smiley faces are being supplied by a workload outside the cluster, it all just works. One of the things that I do in the other mesh expansion demo, thank you. Actually, we should be thanking the Boolean engineering folks. One of the things that we do in the other one is then start doing things like HTTP routes to do canaries between off the cluster and in the cluster, and we could do that, but again, we're already an hour and 10 minutes into this, so I think we're going to stop here and then go over some gotchas and take some questions if there are any.
Yeah, I think it's good to note that all this stuff is out on documentation, both in buoyant.io or docs.buoyant.io and on the linkerd.io site. And if you go through all that, you're going to find a lot of this stuff in there documented and, ready for you to play with. So,
and if you don't find it documented, then that would imply that we did something wrong, and it would be really nice to hear about that.
Yeah, absolutely. Speak up on the Linkerd Slack or in the forums and say, hey, I think we should have some docs on this, and this is why. And we're always writing docs constantly.
It is a never-ending thing. Let's talk a little bit about gotchas. There are a few, and this is a thing that we always do in the Service Mesh Academy deep dives and such. One interesting one is that you cannot currently configure when HAZL is going to decide that it's okay to cross zones. That's the reason why the demo didn't work with 2.15.1, but it did with 2.15.2 because 2.15.1 was much more willing to cross zones than 2.15.2, and I couldn't configure it. I'm given to understand that this is a thing on the roadmap, so I'm optimistic there.
It's not well documented. It is, you can adjust load bands. It's one of those things that so few customers that are using it have needed yet. It works pretty much out of the box for most folks, but it's one of those things as a customer, you would just open up a ticket and we can, basically give you guidance on it. We haven't fully documented that yet because we're still learning, what works really, really great with people. And like Flynn said, from .1 to .2, and I had the same thing. I had some demos that I had to make some adjustments to, but in a positive way, right? So we're moving towards tightening things up. We're just doing it cautiously because we don't want to get too aggressive on these things and have people go, hey man, it's, not doing what it's supposed to in my environment. But we've run it, personally, I was in on a couple of demos with big companies with big workloads, and we turned it on and it was 40% right then and there. And then you go through and look at, oh, why is this talking across zones? Oh, because we need to put a replica over here, right? You turn that on and bam, a whole lot of traffic goes away. So it's really, a great tool for not only reducing that, but, for identifying conditions that aren't normal running conditions with traffic. Maybe you're getting an attack, maybe you have something failing, and for also knowing kind of what your normal traffic looks like and, where things should be, right? So it opened up a lot of eyes for this customer, and they were like, wow, yeah, all right, we should be doing this. So
even, just going through and putting this demo together, it was very instructive to watch what was happening, when it was happening, and all that kind of stuff. Faces is a really simple demo, but it was designed. Faces was designed to show off the fact that even a simple microservices application has a lot of complexity going on. And so, yeah, it was pretty fascinating to look at some of this stuff. But I guess I should probably be saying you can't easily currently configure when HAZL decides that it's okay to cross zones rather than you can't do it at all. So
yeah, and you don't really necessarily want to, once you get to that point, if you've got an app that just behaves a certain way, it is adjustable. It's just one of those things we haven't had a request really yet of someone saying, hey, I want to change this because it's pretty good, out of the box.
It's, to your point as well, when you turn it on, you're going to learn a bunch of stuff, and it would not make sense to start trying to mess with things until you've really internalized what you're learning.
Yeah, why is this coming across? And again, some things that are handy for that is if you've got like internal Grafana or Datadog dashboards, things like that. We've got some queries that are canned that I've built and some other folks have helped me build that we can share that will help you look at things like same AZ cross AZ traffic, by workloads and things like that you can plug into your own installations and take a look at what's going on. So
second gotcha. The client workload, when HAZL is enabled, each of the client workloads makes an independent decision about when it should be crossing zones and when it should not. So you remember I was talking about why I was pointing the load generator at the face workload instead of pointing the load generator at the color workload. It's because one of the really fascinating things that happened on here, talking about complexity. So I fired up the load generator talking to the color workload and cranked it up and still got all blue faces in my browser. Even though the point of the faces demo is that you, a human, should be able to look at the smiley faces and get an intuitive grasp of what's going on. What was going on was that the load generator workload was making a decision that it needed to cross zones, but the face workload was seeing that it was still getting a pretty decent response and it didn't need to do any load crossing, even though the color workload as a whole was getting hammered. On the one hand, this is pretty cool, right? It's like doing the zone crossing from the load generator was sufficient to keep the load on color east below the threshold where the GUI was going to notice. That's amazing. On the other hand, it made the demo not work very well in terms of just getting an instant intuitive grasp of what was going on. So instead, I modified the load generator to point at the face workload. So now it's one workload generating all the traffic to the color workload, and you can see it in both places.
Yeah, it's amazing. And, like I said earlier, when you were resetting, this also works across, in a flat network, it'll work across clusters if you're not using gateways. And that is because everything, you're building one giant mesh, each proxy, joins together in these data planes, and each one is making routing decisions every single request. So it's not like topology or routing where you're just pinning things in a very vague and general way, right? Every time it's got a request at every proxy, it's saying, what is the best place to send this? So it's very granular and quick.
One of the things it sounds kind of silly, but it is extremely cool when you start digging in under the hood and start getting a better sense of what's going on. There's some really cool stuff you can see when you start playing with multi-cluster, particularly with pod-to-pod multi-cluster. It's cool. And you get a bunch of those things as well with when you start doing mesh expansion stuff. It's also remarkable to see, oh, hey, that's not even in the cluster anymore, but whatever. I don't care. I can use it like it is.
Yeah, it's a proxy, right? So it's just like a pod sort of, right? And except it lives outside the cluster. So it's going to behave the same way. And that's why we can do these things. We're talking flat network multi-clustering or, external workloads and using HAZL. It's just another proxy.
And so the fact that each HAZL client is making its own decisions, that is definitely a feature. But the first time I saw it, it was very confusing. So I wanted to call it out as a thing that, hey, be aware of this. That is expected behavior. And finally, yes, mesh expansion is definitely tricky to get set up right now. Our next Service Mesh Academy, we're going to be doing more on the mesh expansion thing, where we are going to be showing off the easy way. That'll be fun. And finally, Tom's right. There's validation around the control plane resource. If you get it grossly wrong, then the API server will tell you, and it's okay. On the other hand, it's very easy to do things like include the wrong Buoyant license, for example, or typo your API client ID, or pick the wrong version. Not that anybody would have done that recently. So yeah, be careful with that. And this is another area where I'm hoping to see a little bit more automation so that we can go and make some of this a little bit simpler to deal with. But those are the gotchas that came to mind while I was doing this that I wanted to make sure we called out and make sure that people had in mind. This is, in fact, the way to go to get started with Buoyant Enterprise for Linkerd, which is the thing we were running today. Strongly encouraged that you go and do that. Like I said, next SMA, May 16th, Linkerd outside of Kubernetes, the easy way, as opposed to the hard way that we've done all along. And I believe that is it. If anybody has questions, now is a great time. Alternately, we can let people have 15 minutes back.
I'm watching the Slack. So
cool.
I think you just did such a great job that everybody just is blown away.
Or everybody's just dazed.
And if you want to see more about the actual mesh expansion part, go check out the SMA page, and there's some other previous stuff on that. We've got some blog posts, and definitely look into the documentation. I know I've thrown the link up, but I'll throw it up one more time. And I think this is the best one. But on the Linkerd docs for 215, there's a couple different items in there and features and tasks that lead to more resources for doing mesh expansion. And so again, if you're playing in your lab, just make sure, I think they all have to be in the same network, right?
Yep.
And then there's some other things that go along with that. But it's just like doing multi-cluster across flat network, sort of.
Yeah, the technical requirement is that you have to have direct IP connectivity. Mm-hmm. And if you're doing it with Docker, you need to just stick them in the same Docker network if you're doing things virtually. Yep. If you're doing it with real hardware, which if you look in the 215 mesh expansion directory, there is a set of instructions for how to do this with real hardware.
Yeah.
And in May, we will be doing this with real hardware as opposed to doing it all with Docker. Networking requirements with real hardware can be a little bit more complex. Let's just leave it at that.
Tune in and find out.
Yeah. I don't mean more complex in the sense of you have to do some special thing just for mesh expansion. I just mean more complex in the sense that, you got a box here and then you got a box that's 4 network segments away. Well, okay, you got to make sure your routers work.
Yep.
That sort of thing.
You got to bring more to the game.
Yeah. It was very entertaining going through and setting up my Raspberry Pi cluster and remembering all over again why I stopped being a sysadmin professionally.
Well, we got no questions, so
I think we can go then. Thanks much for tuning in, everybody. Appreciate it. Thanks for hosting, Tom.
We'll welcome.
Do it again sometime.
We'll see you guys out there.
Have a good one.